Well, we are talking on marine and freshwater microbiology as the current topic where we are talking is freshwater treatment or drinking water treatments. And we have discussed in detail the slow sand filter, which can be installed in small villages or can be used in individual houses where electricity is not available, power sources are not available. So such type of water treatment systems or plant can be installed in remote areas, in villages, in developing areas. So here we have to talk the next step, that is a rapid sand filtration. It is also a technique used for the filtration of water, filtration of drinking water, removal of insoluble particles, suspended particles from water, and to make it clear and suitable for drinking purpose. That is called rapid sand filtration. So this is the diagram of rapid sand filters. This is little bit complex and complicated and a little bit difficult to operate, and it have more mechanical compared to slow sand filter, but it have potential to filter more water compared to that, and comparison we will make in another slide. So here also we have to make a tank in ground. Okay, this is a big tank in ground, and it is total depth maybe here not mentioned. So at bottom, similarly, we have to keep the undrained system. We have to keep a pipe at bottom of the tank. Here, it is a pipe at bottom of the tank, and above that pipeline, there are gravels. 400 to 600 gravel bed must be there, and that will be followed above the gravels, bigger gravels. We have to keep the sand 600 to 700 and above the sand, this must be free for the inlet of the water. The pipe system is little bit complicated over here. If you will see, here is a wall that is called A wall. Here is a wall that is called C, used for drainage. Here A is used for influent to take the raw water from outside, and here we have to collect the drain after washing, and here are B and E pipes are present where we can use for the effluent, and here it can be controlled. And here is a above tank, wash water tank, which can be installed over here, and wash water through also can be done from this source also. So water level during filtering, we must have to inlet the water, we must have to enter water from this A wall. Okay, how filter operates? Open wall A. This allows influent to flow to the filter. If you will open the wall A, water will enter into the sand bed. It will pass from sand bed to gravel bed, and from gravel bed to it will collect into the drainage pipe. In this pipeline, it will be collect over here. So open wall B, this allows water to flow through filter. If you will open this wall B, what will be? The water will start travel from downward from sand bed and gravel bed, and filtered water will come out from this B valve. During filter operation, all other valves are closed. Just we have to open valve A from where raw water will enter. It will fill in this above region which is empty. It will be filled with water. And when we will open the valve B, water will start from here. It will pass from sand bed. It will pass from gravel bed and will come out from the valve B. How suppose the same problem after some time that uh, biofilm layer will accumulate, will form on surface of this sand bed. It will accumulate, it will, biofilm will form on surface of. Okay. So for that purpose, we are using backwash. We are giving reverse flow to this sand bed and gravel bed, reverse flow of water to clean the, to remove the accumulated material from sand surface, to remove the solid and suspended particles which make a layer on surface of the sand. We have to give a backwash. For that, how we are operating the system, close wall A, we have to close this wall A. Okay, what will be? And close wall B, because it have to carry for the fresh water. We have to close this wall B. When water after drops down to the top of the outer floor. So what will be? When we will close this wall, this water will fall from here, it will reduce, and we have to open the wall C. Open wall C and D. We have to open wall C and wall D. What will be? Our other walls must be closed. This allows water from the wash tank to flow up through the filtering medium, losing up the sand and washing the accumulated solids from the surface of the sand out of the filter. Filter backwash water is returned to head end of the treatment plant. So what we are doing, we have to open this wall D. Water will come from here, and it will go from this side, from the sand bed, from the. Okay, sorry for inconvenience. When the output of this filter or efficiency of this filter will reduce, we have to give a backwash to it. For that we are using this tank, and from here when we will open this valve G, water will come from this tank with pressure. It will go inside this gravel and inside the sand. Whatsoever material was accumulated on surface, it will lose it, and it will go from this side and will come out from the drainage. C and D. This allows water from the wash tank to flow up through the filtration medium, losing up the sand and washing the accumulated solids from the surface of the sand, but sand out of the filter. Filter backwash water is returned to the head end of the treatment plant. Okay. How to filter to waste if used. How to filter to waste if used. Open wall A and E. Open wall A and E. Okay. E. All other walls must be closed. Effluent is sometimes filtered to waste from a few minutes after it has been washed to condition the filter before it is put into the service. So whenever we will give backwash, what will be? The problem will be this, that all material will be mixed and it will contain many types of material. So for that purpose, we have to do this activity, how it to filter the waste. So whatsoever surface material was there, we have This is the comparison of a rapid send filter and a slow send filter. Suppose properties, area, rapid send filter covers a small area and slow send filter covers a large area. Rate of filtration liters of water per meter square per hour. Rapid sand filter is given 4,000 to 7,500 water, and slow sand filter is given less water, 100 to 400. Sand size which can be used in filters in diameter. In rapid sand filter it is zero point 0.4 to zero point 0.7 mm, and in slow sand filter have to use zero point 0.2 to zero point 0.3 mm. Pre-treatment, coagulation and sedimentation can be done in the rapid sand filter, and in slow sand filter just sedimentation will work, that all solid materials will settle down. Filter cleaning, backwash and scraping. Filter cleaning, here in rapid sand filter we have to wash the backwash which we have mentioned from our head wash tank, we have to open it, and just in slow sand filter we can use scraping. We can remove mechanically the layer which has been formed on surface of the filter. Operation, it is more skilled or more complicated, and slow sand filter it is less skilled. Removal of color, rapid sand filter is removed good, and it is also better. Slow sand filter is bad. Removal of color. Removal of bacteria, microbes can be removed by rapid sand filter is 98 to 99%, and here it is 99.9%, almost 100% efficiency. Pure water storage, storage needed. In slow sand filter, no storage is needed. So these are the properties of the rapid and slow sand filter. So from here we can see that rapid sand filter can be used in, uh, it can give more water, so can be used for more population, so it can cover, but it can be used only in individual homes. So drinking water treatment, number one, how we can treat this? Number one, clarification, primarily a physical process, but may be added by the addition of the chemicals. That is called clarification. First, we have to remove solid suspended materials from surface. If solid soluble chemicals are too much, we can add other chemicals for coagulation or for flocculation. Then it can be subjected for the filtration. Also, primarily physical, but chemical may add the process. Disinfection, typically a chemical process that reduces pet microorganisms from water. Clarification of drinking water. Clarification removes particulates that contribute to turbidity and contamination of water. So what is the clarification? In clarification, we are removing all solids and suspended particles from the water, which are responsible for the turbidity of the water, and basically called contamination of water. So aesthetically, that is not acceptable. Such people, the water which is turbid, people will not like to drink it. Clarification is added by chemicals which cause particulates to aggregate, precipitate, and form sediment or sludge. Clarification is added by chemicals which cause particulates to aggregate, precipitate, and form sediments. So filtration, in filtration, it separates non-settlable solids from water. Combined with coagulation, clarification, filtration can remove 84 to 96% turbidity. It can remove coliform bacteria, 97 7 to 99%, and 99% Giardia and etc. So filtration is the most suitable and acceptable. Up to this stage, whatsoever activity or strategy is used for the treatment of water or for clarification of the water, that is filtration, because it is going to be more and more and more advanced. Filtration is the only suitable and acceptable strategy for filtration and clearance of the water. So rapid filtration use gravity, faster flow. Slow filtration use gravity but slower flow. Pressure and filter use water pressure. Diatoms earth filtration. Micro straining use fine steel fabric, sometimes used prior to other filtration. Micro strainings are can be used. And which type of filter media can be used? The filter media should be coarse enough to retain large quantities of fluff, sufficiently fine to prevent passage of the suspended solid, deep enough to allow relative long filter run, granular medium filter such as rapid sand filter, anthracite on the very top, least dense, fine sand on top of the supporting course, sand less dense, which lays on top, gravel layer, highest density. Cleaning backwash filters, determination of how often to backwash can be made on the basis of head loss, pressure loss, loss of water quality, increased turbidity, or time since last backwash. Backwash process, water flow is reversed through the filter bag. So what we are doing, water flow is reversed through the filter bag. The rate of backwash is designed to partially expand, fluidize the filter bed. Suspended matter is removed by shear forces as the water moves through the fluidized bed. Additional cleaning occurs when particles of the bed abrade against each other. So flow control through filters, constant rate filtration. Flow rate is controlled by limiting the discharge rate. So after this we will stop it, and in next class we will talk in detail. Okay, have a nice time.